I'll do green because I'm going to use black for autonomics. So what happens is, this sensory nerve that comes in will synapse with another neuron right here. Okay? And then this neuron can actually go down and synapse with a motor neuron. So what happens is, sensory comes into the spinal cord, this thing called an interneuron, between neurons. This interneuron will take that signal down to this motor neuron. It goes out, signals, and makes the muscle move. That's a reflex arc. Controlled in the spinal cord. It doesn't have to be processed up in the brain. Yes, sir?
So what if you have to stimulate a muscle on the dorsal and ventral side?
At the same time, you'd be taking multiple neurons. Right, right. So you might have another interneuron coming down and stimulating. One goes to a dorsal, one goes to a ventral. So what you're saying is, if I get the patellar tap, I'm going, I don't know. That's an interesting thing, but in theory, yes, you have multiple, and you have to understand, you're never going to have like one neuron and whatever. But I just want you to understand the simple complex of it. Okay? Yes, sir?
So gray matter is full of cell bodies?
Gray matter is full of cell bodies. Why is the gray matter gray? Does not have myelin associated with it. The only part of an axon that has myelin is the axon. So that's why the white matter out here is white, is because what you'll learn in neuroscience and some other things is that, yes, these things come in, but like, how do you get axons to travel up to the brain or to other regions where they need to? They're going to come out in these little columns out beside the spot, besides the H of the butterfly, and travel up or down in these other areas. And so these are white because all these are axons. This is where all the cell bodies are situated. Yes, sir?
I thought that when he showed a picture of a reflex arc, part of it seemed myelinated, the other part didn't. He was saying something about how part of it has to be faster than the other.
Well, understand, and I don't really want to get into it. Don't worry about it. Just understand what a reflex arc is. Okay? Let's don't worry about myelinated or unmyelinated axons. Okay? Typically, a lot of sensory neurons coming in are going to be unmyelinated axons. Motor axons are always going to be, I won't say always, but almost always myelinated. But that's nothing you need to worry about. Don't complicate the process down. Just understand sensory in, interneuron, motor out for a reflex arc. And really, I wouldn't even worry as much about the reflex arc, but it's just understanding, really, I want you to get sensory in, motor out. Okay? So if you cut a dorsal root, you know, what would you be losing?
Sensory.
Sensory information only. Okay? Now, probably what's going to happen is you won't get a motor response. The motor part still functions and functions fine, but if you're not getting the sensory input in, you know, you have no way of knowing, you got to respond. So it's kind of like you're sitting there with your hand on a hot stove and it's burning the heck out of you, but you don't get any sensory information coming in. It's kind of a bad deal. Okay, does everybody understand this general concept? Yes, ma'am.
So you said that in the ventral horn there's 2 cell bodies?
No. Well, in the ventral horn there's 5 million cell bodies. Okay? What I'm saying is, in the ventral horn are all the cell bodies for your general motor response, either going to the ventral, dorsal or ventral portions of the body.
I didn't understand the 2 neuron systems for the ventral horn. What did you mean about?
Well, hang on. We're talking general system here. So it's a 1 neuron system. So what I'm trying to get you to understand is there's only 1 neuron involved in the general system. Okay, so does that mean if I'm a sensory nerve, you know, coming from, you know, if you're Shaquille O'Neal and, you know, somebody, you step on or stub your big toe, is it only 1 neuron from his big toe all the way up to his spinal cord? Yes. If you're going to be a motor neuron going from the spinal cord all the way back down to his foot, is it 1 neuron? The answer is yes. Okay? Yes, sir.
I had a question about the reflex. Is it part of the 2 neuron system?
I knew this was going to happen. Forget the reflex arc. Okay? The answer is no, it's not part of the 2. Don't be counting neurons on me. What I'm saying is, information into the spinal cord, information out of the spinal cord is a 1 neuron system. Okay? In reality, it's a 10 neuron system, but I'm not trying to get you to get complicated on this. Information in, information out, 1 neuron. Okay? I'll keep you. What else about this part don't you understand? The general system. Yes, sir?
So
what you're saying is sensory is one neuron, motor is one neuron.
If you want to say it that way, I thought that's what I was saying, but yes. I'm sorry I didn't say it exactly like that, but yes. General sensory, one neuron. General motor, one neuron. Yes, ma'am. Just in the interneurons come into play in jillions of places that you don't even need to worry about. Okay? We won't even ask you about reflex arcs. I shouldn't have even drawn it. Okay? I know how students are. So I talked about it. Now it's gone. Okay? Let's forget about the old interneuron there. Yes, ma'am.
Okay, I'm confused about you said, so in and out is one.
Yes.
For autonomic, it's two.
Right.
Have you drawn that yet?
I'm getting to, no, I'm not drawing autonomic. I'm getting there. I just want to make sure everybody understands the general system first. Okay? Everybody with me so far? Awesome. Okay. So, what happens in autonomics? Okay? Two neuron system. Now, first off, I want to make sure, when we say autonomics, there's two systems. There's a sympathetic system, and there's a parasympathetic system. So when I just say autonomics in general, I'm basically combining the two things together. Either arm of the autonomic system, sympathetic or parasympathetic, is the same. Two neuron system. Okay. So the question is, where, and remember, we're talking motor. I'm not talking a thing about autonomic sensory. When you hear me say autonomic, you immediately think he's talking about that motor system. First off, what do autonomic motor neurons innervate? Smooth muscle, cardiac muscle, glands. Always and only. Okay? Smooth muscle, cardiac muscle, glands. Things that you don't think about. Okay? You don't sit there and say, okay, heart, beat for me. No. You don't think about breathing while you're sitting here listening to me. You know, pressure control in the bladder, in blood vessels. That's all stuff that's unconscious control, controlled by the autonomic nervous system. Okay? So, yes, there's a sensory portion of it. Anytime blood vessels, dilate or constrict, the body knows it. Anytime the bladder expands or constricts, the body knows about it. We're not going to worry about that, though. Okay? Understand that, yes, there are autonomic sensory, but we're just not going to talk about them. I'm going to say this and I'll regret it, but for those of you who just really have to know, autonomic sensory is going to work just like general sensory. It's going to say, I have a sensory fiber in the gut. It's going to follow one of these pathways, go right through here, except the cell body even still will be in the DRG, come through, go to the dorsal horn synapse. All sensory follows that pathway. Doesn't matter if it's general or autonomic. Don't care. All right. So, if I'm autonomic motor, two neuron system, so I've got to have two neuronal cell bodies. Where's the first neuronal cell body found? Right here in the lateral horn of the spinal cord. Now, understand, this is going to hold true for everything except for the four cranial nerves that are parasympathetic, and that's going to be an exception to the rule. We'll worry about that later. Okay? Just follow me here. So all sympathetics, T1 to L2, the parasympathetics that are in the sacral part, S2 to S4, all will have a cell body, 10 million cell bodies in the lateral horn of the spinal cord. Now, yes, sir? Can you say the T1, all that thing again? Sympathetics originate from T1 to L2 of the spinal cord. Autonomics are in four cranial nerves 3, 7, 9, 10. And I know every one of you is out there writing in Arabic, 3, 7, 9, 10. But we're going to get you start writing 3, Roman numerals, 7, 9, 10. That's cranial nerve talk. That's anatomical talk. If I keep seeing you writing Arabic numbers, I'm going to laugh and scoff at you and find some way to make fun of you in front of your peers. Okay? So, for the spinal, stuff's coming off the spinal cord, T1 to L2 of the sympathetics, S2, S4 for the parasympathetics, the first cell body's in the lateral horn of the spinal cord. Then what does it do? It's a motor fiber, right? So what do you think the motor fiber is going to do? Go right out here, out the ventral portion, go out the ventral root. It's going to come over here, And somebody will quibble with me later about this, but I'm going to make it real easy. It's going to come in just like this and go synapse in a ganglion. That's autonomic ganglion down there for you, AG or whatever. So it will synapse with another neuron. Remember, 2 neurons in the system. Where's the first neuron found? Lateral horn of the spinal cord. Where's the second neuron going to be found? In a ganglion. What did we say a ganglion was? Collection of neuronal cell bodies in the peripheral nervous system. Really, I should say collection of neuronal cell bodies outside the central nervous system. In a ganglion. Collection of neuronal cell bodies. Yes, sir?
I apologize if I'm being a stickler, because I don't know if this is right or wrong, but does the axon come out of the ventral horn?
Oh, yeah, it definitely comes out the ventral horn. Where I thought you were going to be stickler with me was up here. And you could have been a stickler, but I'm glad you didn't be that way with me. Because honestly, what it really does is come like through this one and then goes out, but, you know, anyway. I should draw it like it really is. It's just going to make people confused. So it comes down and goes like this. And then the second one is going to come out and go over and go some way. It's either going to do this bit or it might do this bit. It's going to go to a ramus and go either ventrally or dorsally depending on what it needs to do. Yes, sir?
And so that where the second cell body is autonomic ganglion, is that what's called?
That's exactly right. It'd be a sympathetic ganglion if it's sympathetic. It's a parasympathetic ganglion if it's parasympathetic.
It's talking about the exact same spot area.
Yes.
Okay.
Yes, ma'am.
Are we going to be learning the names of the
You'll be learning all this good stuff. We're just trying to walk,
Okay.
and then we'll be running later. Yes?
I feel like I'm learning a lot today.
Okay. Well, that's good.
Why am I learning more now than in class?
Are you learning more than in class? I'm not going to make any comments whatsoever. Okay? So, understand general system, general motor, general sensory. How many neurons do I have in the process? 1. 1 neuron for each system. If I'm a general sensory neuron, where will I have my cell body located at? In the dorsal root ganglion. If I'm a general motor neuron, where will I have my cell body? In the ventral horn of the spinal cord. If I'm an autonomic neuron, where will I have my, or system, where will I have my first neuron located? Neuronal cell body. Lateral horn of the spinal cord. Where will my second neuronal cell body be located? In a ganglion. Somewhere. Okay? Now, what happens on this, this ganglion, like I said, can be almost anywhere. And this process is going to be the same thing for our cranial nerve autonomics too. It's just that if it's a cranial nerve, it's not going to start off in the spinal cord. It's going to start off in what we call a nucleus up in the brain. And then it's going to go to a ganglion. So this ganglion part is going to be true for any autonomic. Now, here's something I got to get you to understand, because we've talked about dorsal root ganglion, we've talked about these autonomic ganglia. So while yes, an autonomic ganglion, or excuse me, a ganglion is a collection of neuronal cell bodies outside the central nervous system, all ganglia aren't the same. Okay? Because what type of innervation will these ganglia cells provide? DRG. What are they? Sensory. Okay? What type of innervation do these autonomic ganglia provide? Hence the term autonomic innervation. Sympathetic or parasympathetic. So all ganglia aren't the same. That's a concept a lot of you will struggle with all year long. A ganglion is the same thing all the time in that it's a collection of neuronal cell bodies. But there's just general sensory ganglia, and then there's going to be autonomic ganglia. Now, understand about this ganglion thing. Very soon, when I get in, I'll start talking about cranial nerves. If a cranial nerve has a sensory component to it, where do you think its sensory cell bodies will be located? In a ganglion. If I'm a sensory nerve, whether it's spinal or cranial, I will have a ganglion for my cell bodies. Okay? And that'll make more sense. Don't worry about cranial nerves for now. None at all. Okay? So this system right here, can you see how general sensory, general motor is a 1 neuron system? Only 1 neuron involved getting the information to the spinal cord or getting the information from the spinal cord to the periphery. Okay? Because that's all I'm talking about with this